Yo, what's up guys, and my computer is officially completed. And so today I'm going to be talking about the things I added, the final touches I added, and I'm going to be talking about the Fibonacci sequence and how I coded it in my computer. These are my two small but very important additions to my computer. In the brown right here, these are the output ports. So I have four because I don't think I'm going to have that many devices attached to it, but this means that my computer can output to four separate devices. And then I only have two inputs because I'm really only going to have a keyboard and maybe some other random input later on, but really all I need is actually one. Really I only need one, but I have another one just in case. Now this is very important because this allows me to communicate with my computer and be able to see what is going on. So like with my last computer, I can hook up a keyboard to one of these and then I can output whatever's in the computer to a screen. Since last video, I have also finished up all of the timings. And so we can see here that we have a lot of delay here. And so if you haven't seen my previous videos, this dark blue right here is the control unit. If you want to see a little more about what all these pieces are, I would suggest checking out this video right here. But I have timed everything up. That's supposed to be disconnected, don't worry about that right now. But this control unit is fully working, so it can determine the instructions, send signals to anywhere in the computer, and then kind of refresh the computer and get the next step. So everything is fully working. The control unit, all of the timings are all good. So the computer can run back to back to back instructions. This is something I would not wish upon my worst enemy. I think wiring the computers probably and timing everything up is probably one of the worst parts, but it is now over and we can start to code the computer. So this is the code I used for my Fibonacci sequence program. It is only 9 lines. It's very, very simple, and I want to explain how it works, just briefly. But first, we have to explain what the Fibonacci sequence is. And so for those who don't know, make a line here. The Fibonacci sequence is a type of sequence, and it follows a very specific pattern. So you're given two set terms. You're given 0 and 1. And then all the terms after that are performed by doing this calculation. You take the two terms, so if we want to figure out this term, we take the two terms before it and add them together. So then we go 0 plus 1 is equal to 1. Now what if we want to do this term? Well, that's going to be 1 plus 1, which is 2. What about this term? 1 plus 2 is 3. And what about this term? 2 plus 3 is 5. So you can just keep on going, getting to higher and higher numbers by simply just taking the two numbers before them and adding them together. Now that I've kind of explained what the Fibonacci sequence is, let's look at how this code does that. So first of all, we basically get our two given terms. The 0 goes to R0 and 1 goes to R1. So these are going to be the two most recent terms in the program, and they're very important because we will need to add them many times. And then we have our load 0 to function register. All this does is it sets the ALU to addition mode, so it's going to be adding. And then these two right here add the two terms, so it adds R0 and adds R1, and then these shift the terms. So then R1 goes to R0, and then the output goes to R1. So then if we have 0, 1 right here, we perform our calculation and we get our output as 1, it will move R1, which is 1, to R0, and then move the output, which is 1, to R1. So then it would basically just go from 0, 1 to 1, 1. And then we have our output. So this simply just outputs the current term, which is the result. And in this case, 0 plus 1 is 1. And then this jump function is very important because it causes this to loop forever. And then it jumps to step 3. But it's not actually this line because in the computer, the very first line of code is line 0. Actually, line 4 is line 3. So it basically just jumps back to the beginning of our calculation. So in that way, these 5 lines are repeated forever. And then that calculates the next Fibonacci term. So this is cool and all. I can code it with an assembly. But how can I actually get this into my computer? And if this is your first time watching my videos, I have a compiler. So what this does is this converts the assembly into a binary file, and then it converts that file, that binary file, into a Minecraft schematic. And then I move that to my Minecraft files, and using World Edit, I can actually paste it into my world. Matt Batwings has code on his GitHub repository for making schematics like this. I would suggest checking that out if you're interested in making a compiler of your own. It made this a lot easier. Of course, I still had to modify it for my computer, but it made the whole process a lot easier. So I will link that into the description. But what I can do is I can run this code, and it asks for the file name. I can put in fib, which is the name of my Fibonacci file, and then it says compile it. All right, so it's converted it to an MC file, and then because I've already loaded it to my file previously, it asks if I want to replace it, and I say yes, and so now that is all done. So what we see here is we have our fib text file, and then we have our fib.mc file, and this is the exact same thing, but converted into my computer's assembly code. And then, of course, the schematic file was moved to my Minecraft folder. Now I am in my world, and we can see that if I do //schem, load, and fib, I now have my Fibonacci sequence loaded and ready to be pasted. Then I can paste it right here, which is my program memory, and run the computer. Now all I need to do is flick this lever, and the computer should start. So I'm just going to freeze the game real quick. I'm going to flick this lever, and then I'm going to go over here. Now, just so that it's a little easier to watch, I'm going to turn it up to 10 times speed, and so you can actually see it counting up from the Fibonacci sequence. So I'm going to set the tick rate to 200, and then I'm going to unfreeze the game. So we can see here the sequence is starting, and so we have our 1, and then we should have our 2, which is 1, 0, and then our 3, which is 1, 1, and then our 5, which is 1, 0, 1, and then our 8, which is 1, 0, 0, 1, and we can see that this will go for basically infinity. Of course, there's only 8 bits, so it can only track numbers up to 256, but this is just a simple program that I like to do to test and make sure that my computer is fully working. This week I'll be attaching the screen and the keyboard to my computer so that I can start working on my operating system. So stay tuned for that, but that's all for now. Peace.